Hi, I'm Addison. This podcast by Addison, Brent, and Mike will introduce you to cold spray coating. Cold spray is a deposition-based method that involves firing high-velocity microscopic particles at the surface of a substrate using a compressed gas jet. It was first developed in the 1980s as an improved process similar to thermal spray, a process dating back to the early 1900s. In thermal spray, thermal heat is used to soften particles as they are fired at the substrate. The deposit does not fuse with the part, instead forming a mechanical bond that requires roughing the surface prior to deposition. Due to the fact that thermal spray requires the powder to be fired at a temperature at or above the particle material's melting point, the limitations of this method arise. The substrate material can undergo thermal degradation or be vulnerable to oxidation, calling for more complex and expensive methods. Cold spray was initially discovered by accident by Russian scientists intending to test supersonic flows. When the copper particles flying through the wind tunnel deposited on the obstruction rather than flowing around it, they quickly recognized the potential this new discovery could hold. Eventually, General Electric began to develop it further to use in similar applications to thermal spray as a solution to some of the latter process's key drawbacks. Cold spray operates at a much lower temperature, binding the particles at a temperature far below the melting point. Unlike thermal spray, bonding with the substrate occurs, allowing thicker and stronger depositions. In the cold spray process, microscopic metal, alloy, or composite particles are accelerated to around 1,000 meters per second. The ideal velocity varies according to the size, melting point, and ductility of the deposited material. As shown in the image, slower velocities will result in lower deposition rates and too little deformation of the particles that manage to stick, while higher velocities will cause a crater-like effect. In this video, the particles were increased by size by 10 times to be able to see the process. Due to the increased size, the deposition efficiency is very low. In more efficient processes, it can reach upwards of 90%.
Hi, this is Mike speaking. When the particles collide with the substrate surface, rapid plastic deformation occurs, disrupting the oxide films on the substrate and particle interface. This in turn creates a strong mechanical bond with low oxide content. The bond is further strengthened due to particles existing in a solid state upon impact, which results in more compressive residual stresses within the bond. Unlike the tensile residual stresses that arise in thermal spray methods, compressive residual stresses enhance recrystallization at the substrate and particle interface. A high rate of recrystallization is indicative of stronger metallurgical bonding compared to that of thermal spray processes.
Hi, this is Brent. At first, the method was used mostly to repair aircraft components made of lightweight alloys. The largest application today is to repair U.S. Army helicopter parts constructed from magnesium alloys. In this case, cold spray is used to rebuild damaged or corroded sections of the part because magnesium cannot be welded. Other popular uses include making thermal barrier coatings and adding corrosion protection layers. More recently, GE Global Research has developed techniques to use cold spray as a true additive manufacturing process used to build 3D geometries.
Thanks for watching. We hope you better understand cold spray coating.